So in question number 4, we're given a rather interesting conceptual question. To help answer this, I'm going to remind you of what the formula for calculating R is. So remember that R is the sum of all of the z-scores for x times all of the z-scores for y divided by n minus 1. Now, what they're asking here is that if we were to do a correlation, and we already have x and y, we get 0.35. Then they're saying, what if we double every single x value? So if we start with x, and we said that our x values were 10, 20, and 30, then in our new xy table over here, we would end up with doubling 10, which would be 20, doubling 20, which is 40, then doubling 30, which would be 60, and so on. Then they say, okay, well, for the y's, we would like to decrease them by 0.20. Well, if you decrease all of your y's, that's basically saying we're going to take 1 and subtract 0.2. Take 2 and subtract 0.2, and so on. 3 minus 0.2. So that you would end up with all of your new y values in orange over here. Well, when we did our studies of descriptive statistics, that means our average and standard deviation, here's what we found out. We learned that if you do this right here, where you take these and you double them, so even if you multiply them by 2, there's something interesting that happens. So even if you double right here, the doubling effect actually will double every single descriptive statistic, including the standard deviation. So what actually ends up happening is the z-scores in orange here, these zx's, are actually going to match up with these zx's over here in green. So the orange zx scores would be the exact same as the green zx scores. Then it says, well, okay, what about the y scores? Well, because we subtract 0.2 from all of the y's, something else interesting happens. The average moves, as does the standard deviation. So all of these green zy's are actually going to match the orange zy's over here. Well, then it says, well, wait a minute, what if I swap them? Here's the beauty of this. And I say beauty, and I don't say that word very often. Remember, when you multiply, this blue zx right here is one number. This green zy right here is another number. It doesn't matter if I say blue times green, it's going to be the same thing as green times blue. Whatever order I multiply these in, I'm going to get the exact same number. So we already know that it doesn't matter if they're a green z-score or an orange z-score. They're going to be the same so long as they're both talking about x's. So even if we swap the x and the y, this top value up here is still going to be the same, and the number of data, n, is also going to be the same. So it doesn't matter because we're still going to end up with the exact same correlation value that they started with. So the answer here is A.